Well, we will start. Welcome everybody to our second semester of this series of expeditions in experiential AI. Remember that in 2 more weeks, we will have our also second series for this semester, the Distinguished Speakers Seminar. And today I have the pleasure to introduce my colleague and friend, Tina Eliassi-Rad. She's a professor at the Computer Science Curie College of Northeastern University. She's also a core faculty member at the two institutes, the Northeastern Network Science Institute and also our institute, the Experiential AI. She has a lot of awards, has done many talks. He got a PhD in computer science from University of Wisconsin-Madison. And her recent work focuses on responsive AI, which is one of the main topics that we want to push at the Institute. So today she will talk about just machine learning. And thank you, Tina, for being here.
Thank you, Ricardo, and thank you for inviting me to speak with you all. So I have a project called Just Machine Learning, and when I give this talk, I just use that title because I'm too lazy to pick a different title. So let's start from the beginning. Machine learning, the term, was coined by Arthur Samuel, and he called it the field of study that gives computers the ability to learn without being explicitly programmed. And that was back in 1959. And what you're seeing here on this slide is Arthur Samuel with his checkers playing program, which was the very first machine learning program. And it wasn't generalizing the way we think of these days. It was basically memorizing every state of the game with the terminal reward of having been in that state. So nowadays, though, when you think about components of a machine learning system, somebody comes and gives you a task and you either collect data or they come with data. And then what you do is you pick a mathematical or statistical model that you feel is suitable for the task. Here, it's a feed-forward neural network with 3 hidden layers. You pick a loss function and an optimization algorithm that will enable you to find the right parameters for your model so that you can minimize that loss function. Now, of course, there have been many people who have done excellent work on the issues with the setup. So first, data, right? A lot of people have spent a lot of time on watch out for the data is biased, etc. One of the excellent works that is a positive work was published by Timnit Gebru et al. About data sets for data sheets. You can think of this as a long birth certificate for data sets. What was the motivation for collecting it? How was it composed? The collection process? How did you pre-process it, clean it, label it, etc., etc.? And this is very nice. And of course, nobody does it because it's a lot of work. But we need to have professional norms where we actually do have these kinds of long form birth certificates for our data sets. Why this is important, in addition to everything that you have heard, there are these historical issues. So back in December, there was this story that these oximeter that we're using for COVID, right, to see how much your body regulates oxygen, doesn't work very well in dark-skinned people. Now, if you do just a little bit of research, you will find out that this problem that was highlighted in 2020 was known in 2005 and 2007, and people wrote about it. And then if you look at that paper in 2005, you see that people in 1992 knew about it. Then you would see that people in 1990 knew about it. Then you see that people back in 1987 knew about it. Just imagine all the data on oximeters that have been collected and that have been fed into machine learning models for medicine that are using this data, right? And so this attention to who's collecting the data, where is the data coming from, do we know historical problems with the data, is something that is very important. However, oftentimes machine learning people don't bother with it. in part because machine learning people treat data as gospel, right? They don't want to do, it's like window washing. If you really want to look at the data, where it came from, clean it, etc. And there are companies that are in the business of curation of data, right? Because nobody wants to do it. As I said, it's like window washing, but it's extremely important. So a couple of years ago, I started working in the criminal justice system with my colleague, Debbie Ramirez, who's a professor at the law school here at Northeastern. And we were looking at algorithms that are being used in the criminal justice system. And she was saying, can we generate aspirational data? And the definition of aspirational data was synthetic data from ideally fair circumstances. And so the question is, how are you going to generate ideally fair circumstances? So if you collect data in our society is not ideally fair. And even if you pay close attention to that data and try to remove its biases, etc., you're still going to have issues that are present in that data. And so when we started thinking about this ideally fair circumstances, it led us to Rawls's work on well-ordered societies. And John Rawls defined a society as well-ordered when it advances the good of its members and it's effectively regulated by a public conception of justice. And in particular, if you look more into John Rawls's work, he had these two principles. One was the difference principle that I'm not going to talk about, and the other one is fair equality of opportunity. And so we said, okay, why don't we create data from a well-ordered society that follows this fair equality of opportunity? And for those of you who don't know what FEO is, it governs the fair allocation of advantageous positions in our society. For example, high-paying jobs, right? Those are advantageous positions, and you want to be fair in allocating them to people. Now, one of the good things about fair equality of opportunity is that it can be formalized as conditional independence. So the idea is that the probability of securing an advantageous position should be independent of protected attributes like race, given justified variables like talent. So here's a small graphical representation of this, right? So you have your justified variable x of j, and given that you want the protected variable, race, gender, etc., to be independent of the outcome y. So this turned our question of can you generate aspirational data to the question of, given an unfair, in the Rawlsian sense, in this FEO sense, outcome, and the capability to alter some of the decision-making processes, how can we satisfy this FEO? Where then we are guaranteed that, for example, we have data, we have a process that's generating data that satisfies FEO. And so we came up with this system called Rawlsnet, which is a system for altering the parameters of a Bayesian network to satisfy FEO. And this work was published in AIES, that's AI Ethics and Society, which is a conference that's run by or sponsored by IEAI and ACM. The work is joint with David Liu and Zohair Shafi, who are PhD students in my lab, Will Fleischer, who's on the call, and is a postdoc in the IEAI program, and Scott Alfeld, who's an assistant professor at Amherst College. So what is Rawlsnet? It has three components. When you give us data, we learn the Bayesian network structure, and parameters. We determine if it's relevant to FEO, and then we update the parameters of the Bayesian network to satisfy FEO if possible. Otherwise, we update the parameters to approximately satisfy FEO. And I'll talk a little bit about why you can't, for example, exactly satisfy FEO in real life, because, for example, your college can only take in so many applicants, so many admissions. So here's an example. So you have college admissions, you have this Bayesian network. The variable that you can control is college. And of course, talent and your socioeconomic status affect your test results. Your test results and your socioeconomic status affect the college you go to. For example, there are all these legacy admissions. You may have heard of them. And Ivy League schools and other rich private schools. And then, of course, the college you went to and your socioeconomic status affects the kind of job you get. And so we are interested in the variables around college so that we can say that the college that you're being admitted to should be blind to this SES. And in fact, as part of this, I forgot to mention this, I did some work with Daniel Allen and Brandon Feidelson a while back that is being actually used in the Boston Latin schools now, about how you would want your college applicants to be geographically diverse, and hence the admission process also being geographically diverse, and how we can reduce the inequality for that. So if you're interested, let me know. I forgot to put a link here. So what do we do is we try to optimize for FEO, right? Machine learning is all really about optimization. And so we have an objective function where we want to find the parameters. These are probabilities in the conditional probability table that would say probability of a job should not depend on your socioeconomic status. And so if you run this system without applying Rawlsnet, here on the left side of my screen, you see different stages of somebody's life. We're only tracking it up to job. We're not tracking it for afterwards. Here's the probability of getting, doing well on the test, the college, job, etc. And normally, as we know in our society, of course, if you have both socioeconomic status, high socioeconomic status, and you're talented, the probability of you getting a job is much higher. But there are discrepancies in that you may have a lot of talent, but not come from a high socioeconomic status. And so the probability of you getting a job would be lower than somebody who has high socioeconomic status. But after you apply the Rawlsnet optimization, we see that we are in a world that we would like to be, where the probability of getting a job is the same regardless of your socioeconomic standing. And of course, there are these feasibility constraints. For example, Northeastern can only admit, let's say, 1,000 undergraduates every year. And so you have to satisfy some of those conditions. And so if you have those, we also added in terms of feasibility constraints. And again, we are in a world that is closer to John Rawls's FEO than not. So then what are the uses of this system? And the code is available online on GitHub, is that you can use it to generate these kinds of aspirational data, which is what Debbie Ramirez was talking about. It can also aid in policymaking. For example, again, in terms of college admissions, if you have a committee of experts that knows what the distribution of talent is, or has a good proxy for talent, then that distribution of talent can be used to run different scenarios in terms of the acceptance rates of different groups that you would need to satisfy FEO. Since I am a data miner as well, and data miners are really good at coming up with names, we named the system Rawlsnet, and we were able to achieve Twitter meme, which is what you want for any paper, where we married John Rawls's political liberalism with Terminator. So now let's go back to the components of a machine learning system. Obviously, a lot also has been said about the model. And again, a positive work here that was published by Meg Mitchell was that if you are reporting a trained model, that trained model should come again with a long form birth certificate, these model cards for model reporting, which it will detail the model, its intended uses, and so on and so forth. And it would have some quantitative analysis. So for example, in this case, you would know that the false discovery rate for old males is high, and perhaps you shouldn't use this model for old males. But one of the things that we were interested in was that even if I have fair data, so for example, I generate fair data through Rawlsnet, should I still worry about the model? That is, if I have absolutely fair data, then maybe I shouldn't worry about the model. Let it just do maximum likelihood estimation and I'm good to go. The model that I learn will output results that satisfy FEO. And one of the things that we found out, and this is ongoing work, is that that's not necessarily true. So just because you have a process that generates fair data doesn't mean that you can lounge around and just give it to any model. We were looking at, and we are looking at, Bayesian networks because, again, FEO can be represented as these independences. So, for example, you could say, oh, well, I need the Bayesian network structure to be correct. I need the learned distribution to be faithful to the Bayesian network structure. I need to have learned the correct joint distribution. And also then it depends on whether you care about asymptotic behavior as opposed to like individual assignments. And then the last part on this plot, this series of components, is task. And usually the task is defined by a company or whatever government agency that wants to use machine learning. And we need to spend a lot of time on actually this task and think about the task itself. This is a paper that was published a couple of years ago on how they wanted to use machine learning to be able to identify and help patients with complex health needs. And what they did was, as opposed to predicting for the illness, they predicted for healthcare costs because it's easier. And of course, we know that healthcare costs are not the same in our society. The privileged have more access than not. And so for a given risk score, they found that Black patients are considerably sicker than white patients. And this gets us to the task of risk assessments. Everybody seems to like risk assessments, machine learning people in particular, because risk assessments is our bread and butter, right? If it's up or down, it's just classification, it's binary. If not, you could do regression, but it's some sort of sorting. It's a low-hanging fruit. And also the human decision maker tends to like them. It's easier for them to understand. And one of the issues actually is with all these risk assessment tools that are out there, especially in the criminal justice system, they don't give any information in terms of the uncertainty that's associated with the risk assessment tool, which is extremely bad. And if you're interested in how humans judge machines, Cesar Hidalgo has a new book that I highly recommend you read. It's short and it's publicly available online, so you don't have to pay MIT Press. So what are the issues with a risk assessment? The problem with risk assessment is that there has an element of mission impossible, right? There are these impossibility theorems. So let's take it from the top. Machine learning people really like confusion or error matrices. This is when Tina says, my model is better than yours, where there is the true condition, for example, whether you have cancer or not, and then what your classifier, your machine learning model has predicted. And obviously you want to have high true positive and true negative, and less false positive and false negative. And depending on the application, for example, false positives may be worse or false negatives may be worse. And from that, you can derive lots and lots of different performance measures that are littered through machine learning papers. So what happened in terms of these impossibility results for risk assessment was that Chudlakova, in a seminal paper in 2016, published the following. She said, suppose I can divide my population into two groups, females and non-females, and suppose that I have unequal base rates. Suppose that the probability of getting breast cancer is not the same between my males and females. And then she also assumed statistical parity. Suppose that the classifier, the machine learning model that you're learning, the probability of it saying that somebody has breast cancer is independent of whether it's female or non-female. And what she showed is that you can't have three measures of fairness that you would like: predictive parity, true positive parity, and false positive parity. And I'll describe what these mean in English in a bit. But you would like to have them. Ideally, you would like to be able to satisfy all of them. Then Kleinberg, the same year, Kleinberg et al. Published another paper where they said, yes, I still have my population, that I'm going to divide them into these mutually exclusive groups, females and non-females. And of course, I have unequal base rates. Clearly, women, the probability of women, females getting breast cancer is not the same as males getting breast cancer. But what I'm going to do is I'm going to get rid of the statistical parity. Instead, I'm going to say that I have an imperfect classifier. And if you come across a classifier that's perfect, watch out for that. And that I have non-zero precision. That is, I don't assign extreme. So there are cases in which, for example, the probability of somebody, female, having breast cancer, given that the classifier says that they have breast cancer, is not zero. And again, they showed that you can have these three fairness measures that you like. Then in recent work with Feidelson, we showed that you don't even need mutual exclusivity. You could have somebody who's female and non-female, or if you want to think about it, black and not black, right? Somebody like Barack Obama. As long as you assume that on equal basis and imperfect classifier and non-zero precision, you won't be able to satisfy these fairness measures. And in fact, you can make it even simpler, where in our work, we showed that as long as you have unequal base rates, you only need a very simple condition, which is that you only assign extreme probabilities to things that are either necessary or impossible. And these are very simple conditions to assume. And again, you can't satisfy all of these conditions that you will like. And there are lots of other kind of impossibility results based on measures that you can get from the confusion matrix, and you can read them in this PDF up here. And if you want, we have a Mathematica notebook that you can download and find more impossibility results for yourself. So what has been the fallout from this impossibility theorem, and what do these measures of parity mean? So computer scientists are very good at bastardizing things because we want them to work. And so one idea is get rid of one of the parities, or put some bounds on the parities. And this may be good when you're in your ivory tower, but when these systems are actually being used in a court of law, perhaps it wouldn't warm your heart that there are some bounds on how badly these parities are being satisfied. So a ray of sunshine here is work by Deborah Hellman, who is a professor of law at University of Virginia, and she's actually thinking about what these measures that you're getting from the confusion matrix mean. And so in her paper, and I believe she's developing this into a book, predictive parity captures what you ought to believe, and true positive and false positive parities are capturing what you ought to do. And if you care about predictive parity in terms of what you ought to believe, then what you are going to do is you're going to rely heavily on what philosophers call the right-making properties. And in our society, the right-making properties are usually folks that are white males with high socioeconomic standing. And so, and of course, they are not the majority, they're just the privileged. And so your system is not going to do well on the marginalized people. And so if you are going to drop a parity because of the impossibility results, the thing to drop would be the predictive parity. Now you may say, what about individual fairness? There's all this work by folks that did differential privacy, Cynthia Dwork leading them, where you would say similar individuals should be treated similarly. Again, Will Fleischer, who is a postdoc in the IEAI program, wrote a great paper about this that was published in AI Ethics and Society last year about what's fair about individual fairness. And he found 4 problems with it. One is that just because you and I are treated similarly doesn't mean that in the global picture we're being treated fairly. The other one is that there's systematic bias in terms of how you decide who's similar. The other one is that you have to come up with features in terms of task relevance, and right there you are going to put some moral values on that, and perhaps your moral values are not the right moral values. This is also where we're working on perhaps one can define a moral distance function. And the lastly is incommensurability, which that there are things that you can't compare with each other, right? Prestige versus money, for example. There are certain aspects of life that are not comparable with each other. And so the takeaways from his paper are that individual fairness is inadequate as a function of fairness. Right before this, we were talking about group fairness, right? I'm dividing my population into females and non-females. And these are the problems with individual fairness. This is not adequate for a definition of fairness. and that individual fairness by itself should not be used as a mean for determining fairness or detecting bias. And in fact, there's lots of folks who are saying, okay, fairness is really a process. And if you talk to lawyers in particular, in terms of the criminal justice system, they oftentimes think procedurally. So far, I've been talking about this machine learning system, issues with data, task, and model. I'm not going to go through loss function and optimization algorithms here. But if you're just looking at this, you're like a horse with blinders on. Because what is happening in this machine learning system is that this machine learning system has a feedback loop with a complex system, which is our society. And complex systems have memory, and they have disorder, and they have diversity and feedback and non-equilibrium, and so on and so forth. And so recently, this was a couple of months ago, we published a paper in Nature with Claudia Marcus, Alexandra Emre, and Nash about how what we're doing now is we live in these societies that are infused with algorithms. So what you do online affects the algorithm, which then affects you in society, which then affects the algorithm. And so there's all these feedback loops in every aspect of our society, from who you date, to what you buy, to recommendation systems, to science, etc. And so we identified 3 challenges. So one is the insufficient quality of measurements. The other one is complex consequences of mismeasurements. And lastly, limits of existing social theories. So just some terms and concepts. Social data, of course, you all know, these are, for example, data that you can capture through Facebook and Instagram and Twitter, etc. There's, of course, this issue of ownership of who owns that social data and what they show you. I'm sure you all know of the recent scandal in terms of Facebook, where they did not give the true data to the researchers and send them on a goose chase for 3 years. And then, of course, there are these social theories, like, for example, theory of balance, where a friend of a friend is a friend, etc. And so in this mix, you're putting in these measurement models where there are approaches, whether theoretical or empirical, that tries to tie high-level social contracts with these observable data. And so there are not only problems with the data, but whether this high-level social construct actually mirrors what you want to do. And I'll go through them briefly. So, for example, the issue with a science article in terms of seeing like who should get more healthcare was that they were measuring the wrong thing. And in particular, you need to pay attention to and be able to justify why what you're measuring is what you think you're measuring. So the first challenge is this insufficient quality of measurements. There are no professional norms. There are no quality standards or guidelines when it comes to these measurements. We all know, God knows, computational models often fail to make their assumptions explicit and test them. This is why machine learning is in crisis in terms of reproducibility. Try to reproduce somebody else's paper. It's a very difficult thing to do. And in fact, there's a conference now in terms of, can you reproduce, the papers that have been published in the top conferences in the past 5 years. And then lastly, the data sets that are being collected and then used for these measurement models and then evaluated, it's not clear whether they're capturing the construct of interest. For example, you were interested in who should get more healthcare. They don't describe or justify how they selected the data. They don't acknowledge or mitigate any of the biases, and they don't justify the criteria or the metrics that they use. And of course, the metrics that you use in your papers to get a paper into a conference is different than metrics when your method hits the road, the real world. So some of the ways to address the insufficient quality of measurements is to actually do multiple measurements of what you want to, of the phenomena you want to study. We're calling that triangulation. And then definitely developing guidelines and best practices so that we have professional norms in terms of documentation, the process of how you're doing your measurements, etc. The second challenge is the consequences of measurements. Obviously, these measurements alter behavior at multiple scales, individual, organization, and society. Unfortunately, there is this perception that the algorithms are more objective And that has an influence on when an algorithm is used in high stakes situations. There is this tension between privacy and transparency, and there is this issue that if you're just evaluating, let's say, accuracy or precision parity or whatever, it will ignore some of the potential consequences, as we saw ProPublica shed a light on for the Compass software. And so some of the ways of addressing consequences of mismeasurement is to reflect on what are you measuring, what should you not be measuring, actually having what Friedman and Nissenbaum talked about, value-sensitive design, having people who these algorithms are going to be used on as part of this process, and developing a responsible computational social science agenda. That is, before the system gets off the ground, you have these discussions. I really like what Latanya Sweeney, who's a professor at Harvard, says, is that if you already develop it and you have a business model, and then at the end you're like, oh, I should worry about ethics, that's the wrong way of going about it. You are doing what's called ethics washing. And then we have the third challenge was limits of existing social theories. These social theories were generated when we didn't live in societies that are infused with algorithms. So if you think about theory of balance or theory of homophily, etc., and they weren't thinking about the kind of diversities we have in our population, the social technical environments that we have that are highly adaptive. And so to overcome this last one, you need to think about, again, the data, the measurement, the theory all at once. You need to be transparent. You need to have a process where whoever you're targeting will be part of that. So this kind of participatory processes for our socially infused societies. And why is all of this important? So I started at like very narrow, okay, here's machine learning, data, whatever. I went higher into, well, looking at machine learning is not enough. Machine learning doesn't live by itself in a cave. It's being operated in our society. And what is happening is that with the use of all these tools, we're seeing more polarization, and we're seeing this democratic backsliding. And that The Economist publishes, and you can look in depth about them. And one of the things that's happening is that we have no good theories to explain this backsliding. And in fact, in the science edition in September of 2020, it was dedicated totally to democracy and balance. And Susan Hyde, who's a political scientist, was pushing for, we should look at, now that we live in these, she didn't call it algorithmically infused societies, we should collect data and we should do what I was just talking about. And this leads me to two papers that we did, and they were shepherded by Carolyn Wiesner. At the time she was at Bristol. This all started from a workshop back in 2018 about, can we think about democratic backsliding as instability in a complex system? And if you look at it from a complex system perspective, then you can come up with not only theories that explain the democratic backsliding that we're seeing, but also come up with policy recommendations. And so the second paper that was published in Nature's Humans and Social Sciences Communications was about policies that you can recommend based on looking at what we're seeing as a complex system. And if you don't know about complex systems, Carolyn Wiesner and James Ladyman have a great book on what is a complex system, and I highly recommend getting it and reading it. And again, I do not get any money for the books I recommend. And so just to wrap up and take questions, again, if you look at the machine learning system just by itself, you're losing out. And a lot of this has to do with what your incentives is, right? If your incentive in working in quote unquote responsible AI is to actually make the world better, then you have to get away from, I just want a paper in this conference, and actually think about it in terms of, oh, this machine learning system interacts with or is part of this bigger soup of complex system that we call our society. And I need to know where it's being used, what are the feedback mechanisms that exist, how much history I have, how much disorder there is, et cetera, et cetera. And so on that note, I'm happy to take any questions.
Wow, thank you so much, Tina. That was wonderful. We do definitely have some questions that have come in, so I'm going to go ahead and get started. The first one is from Ian Paul, and he says, how would one define a metric for talent? The reason I ask is because often talent is defined by a score of a test, and those are usually structured tests. Often, SES affects the ability of an individual to perform in these tests. For example, access to education, books, tutors, etc., especially if one wants to be geographically inclusive. So SES also determines talent in this framework, and this effect can be significant.
Yeah, so we were separating talent from SES. So there was this study, and I don't have the reference in hand, but it was about how there aren't as many women musicians in these concerts teams and tours. And so they did it where like people would walk on the stage, nobody was wearing shoes, the people who were auditioning, because women's shoes usually make more noise, and there's a curtain, and when like they did that kind of test, then you would see that the people who they would accept into their company were more diverse. Now, there's definitely this issue that like if I don't have to work 3 jobs and I can go and pay Kaplan or Princeton Review, perhaps I would do a better job on my test. But determining somebody's inherent talent is extremely difficult. And in fact, that's why the disclaimer of like, if you want to use Rawlsnet for policy recommendations, you would need to talk to people on the ground. So for example, high school counselors, hopefully, you know, I know that that high school counselors in some areas in the United States that are more underprivileged, for example, they have 70 students, so they may not know the talent of their students. But these are societal issues, right? That how can I change how I measure talent so as to have a better outcome down the road? And it seems to me that adding an algorithm there is not the right thing to do, right? What you need to do is actually have people on the ground, right? If you go and talk to teachers and counselors and et cetera, and if you talk to folks who aren't from the top echelon, they all have like a teacher, right? By echelon, I mean the socioeconomic class. They have some teacher that looked at them and said, oh, you are good, right? So Andrea Campbell, who's running for the mayor of Boston, for example, she was raised in foster care. She went to Boston Public Schools, and one teacher saw that she had talent, and she fostered it. And then she ended up at Boston Latin, which is one of the great schools in Boston, and then that led her to Princeton. And so this is where you cannot use an algorithm. And we humans are lazy by and large, and so we want these tests, you know, but if you really want to make change, it starts from grassroots to try to decide what is the talent distribution. There's no easy answer to it. Roll up your sleeves and do the work, the human work.
That's right.
Other questions?
Yes. The next question is from Joe Chow. He says, thanks for very clear viewpoints of fairness. Are there any relationships between fairness and imbalance in data and between fairness and all size fits all concepts?
Yeah, so obviously, like, for example, the work on gender shades that Joy Bugliamini and Timnit Gebru did was showcasing how these facial recognition systems that are being used by, you know, top companies, IBM, et cetera, and are being commercialized, were not doing well on darker skinned people, in part because their data set was not diverse. Now, of course, you can get into quagmire there. For example, Google was like, oh, we don't have enough dark skinned people in our data set. So they hired a contractor and told them, go and get me more pictures of dark skinned people. So they sit down and they're like, oh, where are dark skinned people in America? They're like, oh, Atlanta. So they go to Atlanta and they target college students and homeless people who are darker skinned. And they give each of them $5 and they have them sign a consent form, and then they take pictures of them. Right now, what is your algorithm going to learn? Your algorithm is going to learn just a slice of the population that's dark skinned in America. So you went from one ethical quagmire to another ethical quagmire. But the key is that if you just say, okay, I'm going to make my data perfect, that's still not good enough, right? That there is this whole process that happens when you're going through a machine learning system and how it interacts with the society. And you need to care about fairness at every level, right? And again, this is slow work. This is hard work. This is the kind of work that nobody likes to do, basically, right? If you really look at it, like the people who are doing the really good work on responsible AI are the people who are out in the street doing it, right? As opposed to, publishing NeurIPS papers and other kinds of papers.
Got it. Okay, our next question is from Omar Miranda from goplaceit.com. He asks, how can we diminish the impact of using data that normally correlates with social inequality, primarily financial, then minorities? For example, green urban areas are highly associated with higher income, but using the former can seem a bit innocent.
Yeah, I think part of it, it's a very good question, right? This goes back to data selection. And in fact, I was talking with Citibank for a while there in terms of like who should have their mortgages approved and who shouldn't have their mortgages approved. And of course, like the rural areas are very different than cities like New York, where most people rent, etc. And so just looking at measures like what you were saying about like green space or whatever is not sufficient. This is again where you need to be within that community. I just feel like there is no shortcut on that. Like you need to live in that community, or you need to hook up with folks in that community and see how they live, what's going on, and then with an open eye, collect the kind of data that you want, and also link it to whatever you want to do, the measurement, right? So I want to go back again to that Science article where they were saying, oh, they wanted to do triage in terms of who to help. And to do that, their prediction task was healthcare costs, right? And it goes back, it's in another example of what you were pointing out. And so this is where you need the experienced living, which, one of the things I just want to point out is like oftentimes people will say, oh, look, but we are interdisciplinary. Fine, great, we're interdisciplinary. I work with Will. Will is a genuine philosopher, right? But if you look at the people in the room, oftentimes their social economic classes are very similar, right? Or oftentimes people who have power or are in positions of privilege, right? They have gone to Ivy League schools. One studied philosophy and one studied computer science, but it's very, very similar, right? And so if you really want to solve the problem correctly, you need to include the marginalized people. And the only way you can include the marginalized people is to actually come into contact with them and talk to them, right? Otherwise, it's just, yet another paper.
Right. Okay, our next question is from Joe Fitzgerald. He says, could the equivalent of a carbon tax for harmful or unintended consequences of AI systems be effective to disincentivize forgetting ethics and responsibility? What might that look like?
Yeah, it's a very good question. There has been this discussions of like, should computer scientists have liability insurance, right? It's a different tint on what you were saying in terms of some kind of a tax if like a company doesn't behave well. It's kind of like, this discussion we're having about police having liability insurance, the way doctors have liability insurance. And in fact, there are folks who are advocating for algorithms having something more than the model cards. So these models that are being out for high stakes situations are being used for high stakes situations, actually having a warning system, like a warning label, similar to drugs, because they operate differently on different subpopulations, right? The same way a drug would operate differently, right? And I think actually, if you're thinking about some kind of tax or regulations or liability, looking at the FDA model is the right model. The reason being, you live in America, it's a very litigious country, right? And the reason FDA does well compared to other regulatory institutions in America is because of all the lawsuits with lots of payouts. And so this notion of having some regulatory body is interesting. And now Eric Horowitz, who is the CTO, I think, of Microsoft, recently was saying that he doesn't envision having like something like an FDA for technology, but that each branch or each department would have its own ethics, like tech ethics office. Because like what you perhaps care about in Department of Transportation is not going to be the same as Department of Education. But these are all really good questions that need to be addressed. As is, you know, you can release something out there and somebody will use it, let's say in a court, and the judge will treat it as an expert witness without cross-examining it, and nothing happens to you, even though it could cause lots of people harm.
Right. Okay, our next question and comment. Usama Fayed says, thanks for a great talk, Tina. This is so rich and so filled with content and different dimensions to this complex problem that it can be overwhelming and bewildering. How can we go about systematically simplifying these things and providing a framework for doing the right thing that most organizations could follow as a prescription and at least improve their practices with respect to justice?
Yeah, so very hard questions. Thanks, Usama, for the kind words. That's a very hard question because the idea is, what is justice there, right? What's the notion of justice? For different companies, it would be different things. But I think some of the simple steps could be, for example, what we outlined in our Nature paper in terms of are you measuring the right thing? How is it being measured? Is it, do you have whatever norms you have or you want for your company as part of that data selection? And for example, at Northeastern, we have a really good group of folks that do applied ethics, and actually having like applied ethicists from the very beginning, not at the end or not like some committee at the end, but this is where you would need folks who know the area for that business and also ethicists, et cetera, all together, and what that product was going to be used for. And then start basically from what is the task, how you're going to define it, et cetera, as I was outlining. But it is complex, and you can't say like I am proficient in all applications. So I agree with Eric Horowitz in terms of like just having one kind of FDA-ish thing doesn't make sense. Actually, going back to FDA, they have these documents that they have released in terms of regulatory guidance when you use machine learning in medicine or medical devices. And that would be a good start. But again, FDA is way ahead because, you know, people have sued drug companies and they have paid attention to this.
Great, thank you, Tina. Now, our last question was submitted before the webinar in advance. So I would think we should maybe modify the question to suit your topic today. But it's from Srinivas Vidutha of SS Corp. And he or she, I apologize, I'm not sure, asks how AI has changed the world during the COVID time. And so I would modify that to say, how do you think COVID has affected this type of work that you're referring to?
Yeah, so a couple of things. I will answer the question directly, since I'm part of the Network Science Institute and we've been using AI for some aspects of COVID. But I would say that the use of AI to help us with COVID has been underwhelming. AI was not what you really wanted. Like, it did not deliver if you thought, oh, AI is going to come in, we're good to go, right? There are folks who are working on drug discovery. This is work that I do with Barabashi at the Network Science Institute and a big team of folks where you say, oh, here are natural compounds and drugs, and here are viruses, here's a novel virus, which one it's more likely to bind. This also has its own data issues in terms of that the data that we really want is not available to us, or the way the biologists think about this problem is very different, and we don't have that kind of data. So the way the biologists think about it is that this natural compound is more likely to bind to this virus than this other one. But really what we have is binary, 0, 1. Does it connect or not? There was this challenge, this AI challenge in terms of, there's another paper on COVID coming out, within the next minute. Can we do something like what Don Swanson did way back in the 80s in terms of knowledge driven, like literature driven discovery? That's what Don Swanson was calling it. So for example, by looking at this text, can we find something that we didn't know? So in terms of, for example, Don Swanson's work, he linked migraine to magnesium. And of course, people are using AI in terms of like initializing the parameters of these compartmental models and so on and so forth. So basically marrying what we know about the world and about the virus with the data that we have. In terms of, the angles with respect to social justice, we saw that this kind of a disaster impacts different aspects of our societies differently, right? There are people like me, as Danielle Allen says, that was able to pull up the drawbridge, and there are people who aren't able to pull up their drawbridge. And so looking at what that AI algorithm is using in terms of features to predict who should get a loan or who should get promoted in academia, right? All of that needs to be hashed out. And so I would say AI has been underwhelming when it comes to COVID. Yeah.
I see. All right. Well, I think that does it for our questions. Actually, I think we have just one more. Talking about the FDA, this is also from Joe Fitzgerald. Is the US government really the best equipped to lead the charge for regulations? Won't those regulations just reflect nationalistic interests?
Yeah, there are aspects of nationalism, but you would need somebody, so regulations without teeth, right, are useless. So the question is, who's going to regulate that? And now there are certain institutions or fields that have been fairly good at this, right? There was this Chinese guy who used CRISPR to modify the genome of a baby or something, right? And he was shunned by everybody in his scientific community. I feel like as computer scientists, we're not that woke, right? It's like, oh, look at my algorithm. It's better than yours, right? On these measures, we are in a way fiddling with little things as opposed to working on problems that really matter. There was a paper that came out in the AI magazine over the summer on the grand challenges for AI for the 2020s. The last one was by Raj Reddy, who won the ACM Turing Award back in 1988. And so, for example, they cover health and what they call wisdom in terms of what information should I show to whom at what time, etc. But we need regulations with teeth, and that's where you would want governments involved.
That's
or
excellent.
Sue them and win. Sorry, or sue them and win, but that's very difficult. Very difficult because the consent forms that they have covers everything. Sorry, Amanda, go ahead.
That's okay. No, we're just at time. We have about 3 minutes left. And I just wanted to thank everybody for attending today. And I wanted to thank you for this amazing, hour of education for us all. We will be sending out a recording to this webinar to everybody who's attending. So please share with your colleagues and family and friends. And we'll be back in 2 weeks with our next series, and we'll be sending out more information on that as we get closer to that time. Thank you again, Tina, so much for being with us today, and we'll see everybody soon.
Thank you, Amanda. Thank you, Joe, Rick, Osama, and everybody who attended. Thanks a lot. Take care. Bye-bye.
Take care, everyone. Bye-bye.